Hi, welcome to the introduction for Pichondria, a UPS hat for Raspberry Pi boards. We'll explore Python library installation, working of the board, various settings and usage for this versatile board in this video. Pichondria version 1 is designed to deliver a maximum of 3 amps at 5 volts, ensuring compatibility with Raspberry Pi boards up to version 4. It's important to note that the recently released Raspberry Pi 5 demands a higher current of 5 amps. Due to this increased power requirement, the Pichondria version 1.0 may not be the optimal choice for seamless functionality with the Raspberry Pi 5. Ensure compatibility by checking the power specifications of your Raspberry Pi board before proceeding with Pichondria version 1. To install the Pichondria Python library, kindly execute the following command within your terminal. Pip install Pichondria. Allow the process a moment to conclude, as the pip package manager adeptly fetches and installs the Pichondria library. Following a successful installation, you are well equipped to engage with the capabilities of the Pichondria board using Python. Upon successful installation, it is advisable to periodically check for updates. Regular updates ensure that you benefit from enhanced capabilities, bug fixes, and the latest features. Let's dive into understanding key terms used in the system, where they're applied, and how to use them. This includes things like different voltages, timers, and other settings. Let's start by getting to know the voltages in the system. You can check these using the library, and it's important to note that the unit of measurement for voltage is volts, not millivolts. Additionally, we'll explore the settings you can adjust for a better grasp of the system's voltage aspects. Pichondria works with lithium-ion batteries, and it's important to know their voltage changes based on how charged they are. Typically, it goes from 2.8 volts to 4.2 volts. The maximum supported voltage for lithium-ion cells installed in Pichondria is 4.2 volts. To make sure everything runs smoothly, use lithium-ion cells with a minimum of 3.3 volts during operation. It's recommended to keep Pichondria's batteries in the range of 3.3 volts to 4.2 volts for the best performance. If Pichondria runs below a cell voltage of 3.3 volts without the adapter plugged in, there's a chance that the voltage readings might be wrong, leading to unstable and unreliable performance. Now, let's understand the concept of startup voltage. In Pichondria's operation, it functions optimally when the cell voltage is above 3.3 volts. The startup voltage represents the minimum voltage within lithium-ion cells that must be met for Pichondria to initiate power onto the Raspberry Pi. Before turning on, Pichondria verifies if this minimum voltage requirement is attained. If the specified voltage is not reached, Pichondria refrains from activating the power to the Raspberry Pi. Setting it too high will delay the starting up, as the Pichondria will wait for the lithium-ion batteries to charge to the minimum set startup voltage before powering on the Raspberry Pi. Users can read the current set startup voltage using the function getStartupVoltage, and can set the startup voltage using the function setStartupVoltage. The functions take in and return float values. Now, let's explore the concept of shutdown voltage. The shutdown voltage represents the minimum voltage to which the cells can discharge before Pichondria initiates a shutdown request to the Raspberry Pi. When the adapter is not plugged in, Pichondria powers the Raspberry Pi using the installed lithium-ion batteries. As the cells discharge, there is a noticeable drop in voltage. The shutdown voltage serves as the critical threshold below which the system should undergo a shutdown process. When the cells discharge to a voltage below this predefined shutdown voltage, Pichondria interprets it as a signal to prompt the Raspberry Pi to initiate a shutdown. This ensures the system has sufficient time to power down safely. The minimum recommended shutdown voltage is 3.4 volts. Setting the shutdown voltage too high would reduce the runtime of the Raspberry Pi on lithium-ion batteries before Pichondria requests it to shut down. Setting it too low would mean that the time available for Raspberry Pi to shut down safely is relatively less. You can read the set shutdown voltage using the function getShutdownVoltage, and can set the shutdown voltage using the function setShutdownVoltage. Let's examine the voltages measurable on Pichondria. The input voltage is the measurement taken at Pichondria's input, specifically at the USB-C input port. Typically, this voltage reads above 4.5 volts, when the adapter supplies ample current and voltage to Pichondria. You can measure it using the function getInputVoltage. Likewise, the output voltage is the voltage measurement taken at Pichondria's output, either at the USB-C port or close to the pogo pins connecting Pichondria to the Raspberry Pi. Typically, this voltage registers above 4.9 volts. You can check the output voltage using the function getOutputVoltage. Pichondria relies on lithium-ion batteries to supply power to the Raspberry Pi when the adapter is not in use. As mentioned earlier, the voltage of lithium-ion batteries changes based on their state of charge. Pichondria ensures that it charges these batteries up to a maximum of 4.2 volts and recommends a minimum discharge voltage of 3.3 volts for the lithium-ion cells. To check the battery voltage programmatically, you can use the getBatteryVoltage function in Pichondria library for Python. Now, let's explore the timer functions and terms in Pichondria. Timers are always measured in seconds. Once Pichondria turns on its output, the Raspberry Pi receives its power input, initiating the boot-up process. The Raspberry Pi typically requires a few seconds to complete its boot-up sequence, referred to as the boot-up time. Pichondria patiently waits for this duration before issuing any further commands to the Raspberry Pi. This precaution ensures that critical commands, like shutdown, are not sent prematurely, allowing the boot-up to finish smoothly. You have the flexibility to extend this duration. We recommend keeping it slightly beyond the regular booting time to account for any delays in booting. It is measured in seconds and has a range of 0 to 255 seconds. To adjust it, use the set bootup timer function and check the current set bootup timer using getBootUpTimer function. Importantly, apply any changes made using set bootup timer by using apply settings function to ensure they take effect. Let's now explore the shutdown timer. A shutdown can be triggered via various methods, through I2C commands, pressing the on-off switch, or automatically by Pichondria, when the battery voltage drops below the set shutdown threshold. When the Raspberry Pi receives a shutdown command, it needs time to complete ongoing tasks, save data to prevent corruption, and then shut down safely, before power is cut. There are two shutdown modes, one with acknowledgement, and another without, which we'll discuss in detail later. In acknowledgement mode, the shutdown timer starts counting down once the Raspberry Pi sends an acknowledgement. In no acknowledgement mode, the countdown begins when the shutdown command is initiated by the Pichondria. Pichondria doesn't wait for the acknowledgement before starting the countdown, in no acknowledgement mode. Pichondria counts down, for the time set in the shutdown timer, before turning off power, to the Raspberry Pi. The timer range is 0 to 255 seconds. It's advisable to set it higher than the actual time required for the Raspberry Pi to power down, to avoid abrupt power cuts. To adjust the timer, use set shutdown timer function, and check the set values with get shutdown timer function. Ensure that the changes take effect by using apply settings. Pichondria features a handy function called scheduled reboot. In this mode, you can instruct Pichondria to gracefully shut down the Raspberry Pi and then automatically power it back on after a specified duration. This timeframe, during which Pichondria waits before turning the Raspberry Pi back on after a shutdown, is termed the wake-up timer. The values for this timer range from 0 to 4 billion seconds. The countdown for wake-up begins once the shutdown process is complete. The scheduled reboot mode will be discussed later in detail. To configure this setting, utilize the set wake-up timer function, and, to check the current setting, use get wake-up timer function. Don't forget to apply the settings after making any changes to ensure they take effect seamlessly. Now, let's explore the shutdown modes in Pichondria. There are two modes available, acknowledgement mode and no acknowledgement mode. Let's now explore the shutdown modes in Pichondria, which determine when the shutdown timer begins its countdown. As mentioned earlier, the shutdown timer is the duration for which the Pichondria waits before initiating the shutdown of the Raspberry Pi once a shutdown command is triggered. Raspberry Pi has to periodically check if Pichondria has requested for shutdown over the I2C. You can use check shutdown function in the Pichondria library to check for any shutdown requests. Once a shutdown request is initiated, Raspberry Pi has to shut down to prevent any abrupt turning off of power. Let us understand the modes of shutdown that the Pichondria can work in once a shutdown command is read. Firstly, we'll delve into the acknowledgement mode of operation. In this mode, upon detecting a shutdown request, the Raspberry Pi has the opportunity and ample time to complete ongoing tasks and save data. Subsequently, once the processing is complete, the Raspberry Pi has to send an acknowledgement to Pichondria. Once Pichondria receives this acknowledgement, it commences the countdown to turn off power to the Raspberry Pi. This mode is particularly beneficial when the Raspberry Pi needs to finish tasks before shutting down, preventing unintended shutdowns or data corruption. However, it's crucial to note that, if a shutdown occurs without sending an acknowledgement, such as, if you turn off only the Raspberry Pi, without notifying the Pichondria, Pichondria will wait indefinitely for acknowledgement, necessitating a power cycle of Raspberry Pi, as the Raspberry Pi will not be able to send the acknowledgement, as it is already turned off. To avoid this, it's recommended to always shut down, by requesting Pichondria, and then sending an acknowledgement. Furthermore, a hardware bypass shutdown option is available to recover from this indefinite waiting for acknowledgement, pressing the power button 3 or more times within a second, when Pichondria is turned on, allows shutting down power, without waiting for acknowledgement. Acknowledgement mode is the recommended mode of operation, as it keeps the I2C bus relatively free, and also prevents abrupt shutdowns, as an acknowledgement is always required to initiate the countdown of shutdown timer. In the no acknowledgement mode, the shutdown timer initiates immediately, upon a shutdown request in Pichondria, without waiting for acknowledgement from the Raspberry Pi. In this mode, the Raspberry Pi must frequently check for shutdown requests to prevent abrupt shutdowns. While this mode keeps the I2C bus busier, it is relatively less complex. Let's now explore the various shutdown options that the Pichondria has to offer: shutdown, reboot, scheduled reboot and reboot on power restore. Let's understand how a regular shutdown mode operates. The Raspberry Pi regularly checks for shutdown signals from Pichondria through I2C. Raspberry Pi can also request a shutdown to Pichondria. Upon receiving a shutdown request at Pichondria, it readies itself for a shutdown sequence. If Pichondria is in acknowledgement mode, it waits for confirmation from the Raspberry Pi before starting the countdown to turn off power. Raspberry Pi should send an acknowledgement for shutdown process to start the timer. In no acknowledgement mode, the shutdown timer begins counting down immediately. When this timer reaches 0, Pichondria cuts power to the Raspberry Pi. Once shutdown is complete, you can power up Pichondria by pressing the on-off switch. To initiate a shutdown sequence, you can use the rec_shutdown function in the library. Pichondria can also request a shutdown if the battery is low or if you've pressed the on-off button once to request a shutdown. Now, let's explore how rebooting functions. You can initiate a Raspberry Pi reboot through Pichondria by either pressing the on-off button twice while the Raspberry Pi is on, or by sending the command rec_reboot from the Raspberry Pi. The process of shutting down the Raspberry Pi is the same as in the shutdown mode. After cutting off power to the Raspberry Pi, Pichondria waits for a second before restoring power. The Raspberry Pi will then boot up once power is reinstated. Now, let's delve into the details of the scheduled reboot mode. This mode comes into play when you need to wake up the Raspberry Pi at a specific future time or after a set period. You can trigger a scheduled reboot by first setting the required time in seconds as wake-up timer, and then calling the rec_scheduled reboot function. Ensure that the wake-up timer setting is applied before requesting the scheduled reboot. Pichondria follows the shutdown sequence, cutting power to the Raspberry Pi, and then waits for the specified duration, indicated by the wake-up timer. Once this set timer lapses, Pichondria powers the Raspberry Pi back on. You have an option to skip this timer by pressing the on-off button to turn on the Raspberry Pi. This is to ensure that you don't get locked in a very long wake-up time in this scheduled reboot mode. Pichondria also includes a shutdown mode known as Power Restore Shutdown. This mode proves handy when operating Pichondria on low battery, requiring a Raspberry Pi shutdown to preserve data, with the intention to resume operation once the adapter power is restored. To activate this mode, you can utilize the Rec Power Restore Shutdown function. In this mode, Pichondria follows the familiar shutdown sequence, ensuring data integrity. Subsequently, it awaits the return of adapter power. Once the adapter power becomes available, Pichondria proceeds to power up the Raspberry Pi. As discussed earlier, there's an acknowledgement mode in the shutdown process. To enable this mode, you can use the Enable Acknowledgement Mode function, and to disable it, use Disable Acknowledgement Mode function. If you want to check the current mode, employ the Check Acknowledgement Mode function. When it's time to send acknowledgement to initiate the shutdown timer, utilize the Send Acknowledgement function in the Pichondria library to send the acknowledgement. Pichondria features an autopilot mode, designed for systems that demand maximum uptime and prolonged operation, without human intervention. In autopilot mode, Pichondria autonomously triggers a shutdown request when the battery voltage falls below the specified shutdown threshold. It then executes the designated shutdown sequence, cutting off power to the Raspberry Pi. Subsequently, it patiently waits for power restoration. Upon power return, Pichondria restarts the Raspberry Pi. In this mode, the Raspberry Pi's primary responsibility is to monitor shutdown requests from Pichondria and issue acknowledgement when necessary. Autopilot mode ensures the Raspberry Pi remains powered on for extended durations without requiring human intervention. In short, in autopilot mode, Pichondria automatically uses the Power Restore Shutdown mode, without you having to specifically monitor for battery voltage and issue the command from the Raspberry Pi programmatically. You have the option to activate autopilot mode with the Enable Autopilot function, deactivate it using Disable Autopilot function, and check the current mode with the Check Autopilot Mode function. Pichondria and Raspberry Pi communicate through I2C, with each device on the I2C bus assigned a specific address for communication. Pichondria's settings are stored in an EEPROM at hex addresses 50 and 51, which cannot be modified. Pichondria works on a different I2C address. When the Apply Settings function is called, the settings are loaded from the EEPROM to Pichondria. If needed, you can modify the I2C address of Pichondria using the Set Pichondria Address function. To check the current address, use the Get Pichondria Address function. Be cautious not to set an address within restricted ranges or one already occupied by other devices on the bus. If the bus is empty, it's advisable to retain the default addresses to prevent any complications. Now, let's understand how to check the status parameters of Pichondria, specifically to determine if it is charging the lithium-ion cells and if the adapter is providing power. These values are typically represented as true or false, returned in the function calls. Pichondria offers a feature to indicate whether it is charging the lithium-ion cells. You can use the ease charging function to check if charging is currently in progress. It returns true if charging is underway and false otherwise. In case the adapter is plugged in, but charging isn't happening, verify if the adapter supplies sufficient current and voltage to the device. Additionally, you have the option to adjust the charging rates using hardware settings, allowing you to control the speed of the charging process. To determine if the input adapter is supplying power to Pichondria, utilize the Input Availability function. It will return true if the adapter is providing power, and false otherwise. As mentioned earlier, Raspberry Pi should regularly check for shutdown requests from Pichondria over I2C. The Check Shutdown function serves this purpose, returning true if a shutdown is requested. Upon detecting a shutdown request, Raspberry Pi should initiate a shutdown, adhering to the selected mode, whether it's acknowledgement or no acknowledgement. Neglecting to check for shutdown requests may result in an abrupt shutdown of the Raspberry Pi, either due to a no acknowledgement mode or an empty battery in acknowledgement mode. It's crucial to ensure that Raspberry Pi promptly shuts down safely upon receiving a shutdown request. We have provided a brief overview of Pichondria, its applications, and functionalities. Detailed tutorials focusing on specific functions and addressing common concerns will be featured on our channel soon. These videos aim to assist even entry-level tech enthusiasts in using Pichondria effectively, presenting information in a concise yet detailed manner. Stay tuned by subscribing and following us for these upcoming videos. Thank you.